Welcome to this course on building a web application using Java, Spring Boot, and MySQL. In this first episode of our course, we will cover the following topics. What is Spring Boot and why use it? How Spring Boot simplifies Java web development. Creating a new Spring Boot project with Spring Initializr. Understanding Spring Boot project structure, folders, and files. Configuring application.properties, basic setup. Running a Spring Boot application. Spring Boot is an open-source framework built on top of Spring Framework that simplifies the development of Java-based web applications. It provides an opinionated approach to configuration, making it easier to create and deploy applications with minimal setup. Spring Boot offers several key benefits that make it a preferred choice for back-end development. Simplifies Spring development. Spring Boot eliminates boilerplate code and reduces the complexity of configuration. Unlike traditional Spring applications that require extensive XML or Java-based configurations, Spring Boot offers auto-configuration. Standalone and embedded server. Comes with an embedded Tomcat, Jetty, or Undertow server, so no need to deploy the app to an external web server manually. Run Spring Boot applications as standalone jars. Production-ready features. Spring Boot Actuator provides built-in endpoints for monitoring and health checks. Built-in support for logging, security, and exception handling. Integration with databases and ORM. Built-in support for Spring Data JPA, Hibernate, and JDBC. Easily connect with databases like MySQL, PostgreSQL, and MongoDB. To sum it all up, we can say that Spring Boot simplifies Java web development by eliminating complex configurations. It is lightweight, fast, and production-ready with built-in features. Best suited for REST APIs, microservices, and cloud-native applications. How Spring Boot simplifies Java web development. Spring Boot is designed to reduce complexity and make Java web development faster and more efficient. Here's how it simplifies the process. Eliminates boilerplate code. Traditional Spring applications require extensive XML configurations or Java-based setup. Spring Boot uses auto-configuration, which detects dependencies and configures them automatically. Embedded web server. No need for Tomcat deployment. Traditional Java web applications require an external Tomcat server to be installed and configured. Spring Boot comes with an embedded server, Tomcat, Jetty, or Undertow, so you can run the application as a standalone JR file. Built-in dependency management with starters. Instead of manually adding multiple dependencies, Spring Boot provides starter dependencies that bundle required libraries. Spring Boot Actuator for monitoring and health checks. Spring Boot provides built-in production-ready features like Actuator, which helps monitor and manage applications. Simplified security with Spring Security. Implementing authentication and authorization in traditional Spring is complex. Spring Boot integrates Spring Security easily with minimal setup. Conclusion: why developers love Spring Boot. Less configuration, more focus on business logic. Embedded servers, no need for external Tomcat. Auto-configured dependencies, faster development. Built-in monitoring and security, ready for production. Microservices and cloud-friendly modern architecture support. Well, let's start creating our project. For this, we will use the Spring Initializr, as it greatly simplifies the configuration of the basic project. To create our project, we need to select some parameters. Build system. In this case, we select Gradle. As for me, it is more convenient to configure, more readable, and takes up less code to declare dependencies. Language Java. Spring Boot, leave it as is. Then enter the name of our educational project. Let it be courses and edit the remaining fields. Packaging, leave the same. We will use Java version 21, so choose it. Also, what is convenient in this initializer, you can immediately select the dependencies we need. For now, we are choosing only Lombok, which will simplify our life and reduce a bunch of unnecessary code. But in the future, we will add dependencies to our project as needed. Click the Generate button, and our project is ready. Now we need to open it in some IDE editor. In our case, I will use IntelliJ IDEA. After opening our application, we need to make a couple of settings for our development environment. In this case, we see an error with an incorrect Java version, since I have several of them on my computer, and you won't have anything like this, but I want to show how you can quickly fix this problem. In this case, we go to the Ideas setting and in the Build Tools, select Gradle section. After select the 21st version of Java we need and apply the changes. After that, we go to our main package, then we go down the packages to the main class. Select the Java version for configuring our project. Apply it. Also, a dependency download will appear if you have not opened the project before and you do not have downloaded source files. In this case, there is none and everything is successful. When you create a new Spring Boot application, the project follows a standard structure that makes it easy to develop, maintain, and scale. Let's break down each part of the structure to understand its purpose. This is the main package where all Java classes are placed. Inside, we organize code into different layers following best practices. Main class. This is the entry point of the Spring Boot application. It contains the main method and is annotated with Spring Boot application. Spring Boot application enables auto-configuration, component scanning, and Spring Boot defaults. Next, we will create the packages we need, which we will use later and talk about them. Controller package contains REST API controllers that handle incoming client requests. Service package contains business logic and interacts with the repository layer. Repository package contains Spring Data JPA repositories that interact with the database. Model package contains Java classes that map to database tables. Test package contains JUnit and Mockito tests for verifying code functionality. Build.gradle file. This file manages dependencies, plugins, and project configuration. Now we will try to run our application. Go to the main package, select our main class, and click on Run. The logs open, and we see how our application is launched. In the next lesson, we will create a controller, and we'll be able to clearly see the interaction between our application and the browser. Thank you for your attention. Subscribe to the channel so as not to miss new videos, and see you in the next lessons.